Okay, so for skill 4, started off with this graph and I labeled it like that, and I chose f of x to be the parent sine function, and this is the function I wrote. So to get that function, first I started with the parent function, then I changed the period from 2 pi to 4 pi, so b is 1/2. Then I shifted the graph to the right by pi over 2, so it's now sine of 1/2 x minus pi over 2. Then I did a vertical dilation by a factor of 2 and increased the amplitude. So I multiplied the previous step by 2, so now it's 2 sine 1/2 x minus pi over 2. And lastly, I shifted the graph up by 3, so it's 2 sine 1/2 x minus pi over 2 plus 3. And then I recopied it and I distributed 1/2 to x minus pi over 2 to get g of x is equal to 2 sine of 1/2 x minus pi over 4 plus 3. And so a is 2, b is 1/2, c is pi over 4, and d is 3. And then for part b, I chose h of x to be 2 secant 1/2 x minus pi over 4 plus 3. And then I graphed it here and I drew in the vertical asymptotes, which are the dotted lines. So first, I found the domain, which is all real numbers except for the asymptotes, which are 3 pi over 2 plus 2k pi. So that's the domain. And the asymptote, as you can see, is 3 pi over 2 here, and plus 2k pi just to show that it's like, just to show all the other infinite asymptotes. And yeah, the range is negative infinity, 1, and 5 to positive infinity, because it's going from negative infinity to 1, and then 5 to positive infinity. And the asymptote, as I said before, x is equal to 3 pi over 2 plus 2k pi, because I just used this asymptote first, and then I added 2k pi. So yeah, just to show all the other infinite asymptotes. And this graph is increasing at these intervals and also this interval. So that interval is pi over 2 plus 4k pi to 3 pi over 2 plus 4k pi, as you can see. This is pi over 2, and then this asymptote is nearing the asymptote, which is 3 pi over 2. So it's increasing at that interval. And then I added 4k pi because I wanted to show that it's going to increase here and here, and I didn't draw it, but just going to keep increasing, and also here. And 4k pi instead of 2k pi was added because I manipulated the graph that way, and the b value was, well, the period was 4 pi, so yeah. And then it's also increasing in 3 pi over 2 plus 4k pi and 5 pi over 2 plus 4k pi, because it's just down here. So 3 pi over 2, 3 pi over 2 plus, 3 pi over 2 to 5 pi over 2, and then just added 4k pi. And then it's decreasing in these intervals here, and also it's decreasing here and here, and well, infinite times. And then that interval from this decreasing interval is decreased from this asymptote, which is negative pi over 2, to here, which is pi over 2. So I said decreasing from negative pi over 2 plus 4k pi and pi over 2 plus 4k pi. And then it's also decreasing from here to this interval right here. So this is 5 pi over 2 down to this asymptote, which is 7 pi over 2. And then again add 4k pi to show the infinite intervals where it's decreasing. And then for y-intercept, I just substituted in 0 for x. So I just solved this and then got x to equal, well, y to equal 2 root 2 plus 3. So the y-intercept is 0, 3 plus 2 root 2. And then on the back, I found the x-intercept. So I did this by setting this to 0, and then I eventually got is equal to 2.3, and then x is equal to 6.172, and then that's only 1 because cosine of whatever can equal something negative in 2 quadrants, and the second and the third quadrant. So then I found this angle, because this angle is the first instance in which it equals negative 2/3. This angle 2.3, and then I found the second angle in which it equals 2.3, which is 3.98. Here the cosine 3.98 also equals negative 2.3, so I can also use that. And so I did 1/2 x minus pi over 4 equals that, and then I got x is equal to 9.530. So then the x-intercept is 6.172 plus 4k pi 0, and 9.530 plus 4k pi 0. And again, 4k pi is added instead of 2k pi because of the way I manipulated the graph. That's it.